Happy Monday, everyone. This is Martha with Nature Niche, and this week I wanted to talk to you about pit and mound microtopography. So, I had the pleasure of visiting an old growth beech maple hemlock hardwood forest this weekend. Some of the trees are over 225 years old in the A.B. Williams Woods at Cleveland Metroparks North Chagrin Reservation. And the main characteristic of many of our mature um, woodlands, old growth forests, is this pit and mound microtopography. When you look across the landscape, watch for these small hollows and little hills, and you won't see these in places with a lot of past land use disturbance. They'll get leveled out if there was plowing or intense grazing in the past. Microtopography influences how plants are able to regenerate and get established in a system, how succession may occur through time, and how soil develops locally. Pit and mound micro landforms are generated by the uprooting of large trees, and it's a natural disturbance caused by windstorms that can happen annually and on longer cycles by events like hurricanes and tornadoes. Um, I think, and happening more frequently these days with emerald ash borer killing our ashes, and those dead ashes tending to fall in the wind. The uprooted tree tends to fall with large roots intact, and that rips up a mass of soil as it's falling. And then a depression or a pit is formed where the main mass of the roots were located. So that's termed the tree throw pit. And the upthrown roots and the soil mass form what's called the root plate, and that will form a tree throw mound adjacent to the pit. So pits and mounds are formed often in pairs this way, creating the microtopography. The exact shape of the pits and the mounds that form as the root plate and soil that decay happens and the soil slumps, that's influenced by existing soil conditions, tree size, and rooting habit, as well as the quantity of sediment that slumps or erodes back into the pit. Really large trees, when they blow over, the pit may function as a vernal pool. We talked about those last week. And the pit and mound topography that we see in the A.B. Williams Woods, where I was visiting, is very likely from American chestnut trees that used to dominate this forested overstory, basically dying from chestnut blight and falling over with time and creating more pit and mound microtopography. So where this occurs in the landscape isn't randomly distributed. It's strongly associated with ecosystems with soil and parent materials that favor shallow rooting in the trees, and where there are severe windstorms. So places with wet mineral or organic soils that have a high water table and the roots are forced up towards the surface where there's more oxygen. Rocky soils are those with a root restricting horizon, maybe a hard pan or a really thick clay layer. And then landforms that are high in the landscape, so steep slopes, and especially those exposed to high winds, as well as low in the landscape, where wetlands form and there's a high water table, potentially unstable soils, and again, shallow root systems due to low oxygen availability. So here's an example I saw in the field. This is the root plate from a recently fallen large white oak tree. So you can see the soil and the major root mass, and then here's the trunk of the tree going down slope, and that will eventually decay and become coarse woody debris on the forest floor. So, why is pit and mound topography important? Well, different microsites provide a variety of environments for the colonization of woody and other herbaceous plant species. There's a gap that opens in the canopy from the tree falling, and that allows less shade tolerant species to establish. The wet pit area allows for some more moist soil species to get a foothold. The mound of soil, the surface, you usually have bare mineral soil present without leaf litter covering it up, or competing plant roots, and that's an ideal setting for small seeded, wind dispersed species like hemlock and birch to germinate. The fallen and then rotting tree trunks become coarse woody debris that serve as nurse logs, and that term is because that rotting trunk holds moisture and there's no competition. So those competition-free sites are great for seedlings to get established, and they're especially important in hardwood swamps where there's often a lot of surface water and low oxygen, which isn't very conducive to seed germination. So it allows for woody species and other things like ferns and wetland plants to get a toehold. And it provides lots of wildlife habitat diversity. The mounds can be places for turtles to nest or mammals to burrow. The pits hold water, as I discussed vernal pools last week. Lots of important wildlife life cycles completed in those systems. And the logs are there to provide food and habitat for things like salamanders to nest underneath, and our kind of wood boring insects and native bees and the like to nest as well. So I hope this gives you something new to think about as you walk in the woods. You can think about past land use history and see if you can find some pit and mound microtopography and check out the differences in what types of animals and plants grow in those little microsites. Thanks and have a good week.